Hello, welcome back. Now that you got to know that how exception level 0 and can be used in Linux operating system, let's look at how exception level 1 can be used in Linux operating system. So exception level 1 and talk to exception level 0 very often. So this can be happen using SV assembly instruction that the operation can be called system call. At exception level 1, Linux kernel runs because it has the privilege to access all of the hardware resources, just like the interrupt configuration, and it'll access all of the system register that is surfaced with exception level 1. That means software at exception level 1 can control the peripheral device driver. For this reason, Linux kernel or Linux device driver runs at exception level 1. Another important question is which code can be running at exception level 1. So here is the example code that can be running at exception level 1. That is the body of the schedule function. As you know, schedule function is the core part of Linux operating system, Linux kernel. That is the primary subsystem in Linux kernel. So this is one of the example that this code can be running at exception level 1. So let's look at another example assembly instruction that can be executed at exception level 1. So here, this assembly block is part of the start code, and that initializes the fundamental configuration in the Linux kernel. So as you can see, when you run this assembly instruction, the system control register suffixed with EL1 can be written by the value of X register. So as you can see, so you can write any value onto those kind of system register in Linux kernel. This is the system register, that is TTBR0EL1 register. Here, this is the system register, that is TTBR0EL1 register. The register has the address for the page table that is used to translate the virtual address into physical address at exception level 0. So this system register is used to convert the virtual address into physical address that is running at exception level 0. As for the system register, TTBR EL1 under EL1 register could be used to convert the virtual address into physical address at exception level 1. So here, those two system registers are important when you learn about how the virtual address can be translated into the physical address. Now moving back to the main topic. So any of the system register can be configured. That system register should be suffixed with EL1. So for this reason, the cache configuration can be done or interrupt configuration can be performed at exception level 1. Now let's summarize important point of exception level 1. So as we discussed in the previous lecture, the concept of exception level corresponds to the privilege level. For this reason, exception level 1 is corresponding to the privilege level 1. We can access hardware resources such as interrupt or MMU and cache. This kind of access can be done using the system register. At exception level 1, the software can run essential assembly instruction or HV assembly instruction that require the privilege level 1. So when the Linux kernel execute essential assembly instruction, the exception level can switch from EL1 to EL3. As for HV assembly instruction, exception level can be switched from EL1 to EL2. Those two individual assembly instruction is considered the exception generating assembly instruction. This assembly instruction should be executed at exception level 1 that corresponds to the privilege level 1. Now that we understand the concept of exception level 1 and then how the software can configure hardware resource in Linux kernel at exception level 1, the next lecture we will explore the exception level 2 where hypervisor runs.